Okay. I see people joining, and let me start from the beginning. So, can you see my screen? No? Oh,
Yes,
okay.
I can see.
I probably want to switch, right? Is it good? What you can see?
Yeah, I think now it's the correct one. Yeah.
Okay, that's great. That's great. Okay. Let's we typically start at 9:02, so we can wait for another probably another minute. Cool. Yeah, so how's everything? Yeah.
It's pretty good.
Okay, yeah, that's
Yeah.
great. Yeah. Um, yeah. I think it's our first time to discuss the cybersecurity on webinar, and but I noticed as well it's kind of like a hot topic because for the that's why we have more and more agents, right? For and as long as we have more agents, people are uh yeah people are curious about okay how we can I mean these days where people are like trying to do everything in YOLO mode, right? But I think in the long run I feel that okay yeah in the short run people will find okay there are probably something wrong with the with just the deploying agents, right? And they probably will care about the security. Yeah, so we can discuss something regarding security today.
Yeah, especially after the news about the misery large language model, the new version of Anthropic Cloud.
Hmm. Yeah. Let's wait for another 30 seconds. Okay, yeah, let's start.
Yeah.
Um, Hello everyone. I'm Indri, and I'm a founder of RisingWave. So super excited today to discuss for uh the runtime graph analytics for the cybersecurity, right? And that's what we are living in the super yeah, weird word that everyone just deploying agents and everyone is doing a lot of like random things. Well, in a YOLO mode. Well, I mean, but for every single company, security is probably at the top priority, right? So today I'm super excited to have the chance to talk with Wei, the co-founder and CEO of PuppyGraph on how we can detect the threats as they happen using, I mean, Iceberg, streaming, and graph technology. Cool. Yeah, we more. Yeah. Can you just do a pretty quick, short intro? Yeah, about yourself and about your company.
Hi, this is Waymo. Sounds like the self-driving, and but I took the name first. I'm co-founder and CEO of Puppygraph, and I talked with Injun several weeks ago, and we realized that both of us have some top 10 cybersecurity company as our customer. But the interesting part is that there is no overlap. I think, and writing way with writing to iceberg, and we are reading the iceberg. So we really believe that we can have become a very good combo. And let's share some idea today and to see uh, if there are some big potential.
Yeah, definitely. The thing here that's what we found is that cybersecurity companies are becoming definitely playing a super important role, right? Because yeah, as I mentioned, there are too many agents these days, right? And and people definitely need to care about the security, care more about the security. And I think well, it's a pretty. We have already seen a lot of news regarding, I mean, how people use agents to do damage, right? Well, and to attack, to detect attack, right? So basically, think about okay, so as if what if a token leaks, right? And let's say that okay, we found that okay, our AWS asset key got leaked, and what we should do, right? We should definitely try to detect okay, there's a leakage, right? We should definitely detect first, right? And we should not be like okay, let's just do the detection every single day. We do really want to detect it within probably within seconds, right? Not even minutes, right? Minutes, right? Because well, I mean if we give the attackers, let's say 5 minutes, they probably can do a lot of random things, right? So, and we definitely want to make sure that everything is under control. And also we definitely want to understand, let's say that well, in the worst case, if our AWS access key got leaked, and if we find that okay, some bad guys just use the access key to access our let's say our information, right? Well, and oh, then what's the impact, right? We should definitely know okay whether it impacts a lot of like the customers or clusters or whether it impact our internal clusters, right? Well, we definitely want to have a really clear view about okay, well, the yeah about how bad the attack could be, right? So one trend Wimo and I found is that these days a lot of cybersecurity companies have moved their storage from I don't know from some random places. Well, I mean it's definitely not random places, but some closed source places to Iceberg, Apache Iceberg. And we just discussed about okay why people are moving towards Iceberg, right? And we reach a lot of yeah we definitely reached some agreements. So we more I'm not sure whether you can share something regarding what you observed and how your customers will why your customers choose Iceberg instead of some other existing solutions.
Yeah, I attended the RSA and visited maybe 30 booths, and I think more than half of them is already migrating their storage to some other, maybe Hive, maybe some other data warehouse, and to Iceberg. And the last year, I think still some of them haven't heard about Iceberg at all, but this year, uh, it's became very popular. And I think basically the cost and the efficient cost and uh, also the open format is very important for them. And yeah,
Mhm. Yeah, well, look, for the that's also what I observed. Well, I think 2 years ago in 2024, when I talk to people, people probably don't really know, okay, what iceberg is. I mean, they probably heard about the iceberg. They probably heard, okay, some companies like Snowflake are probably Databricks, well, they are promoting Iceberg. But I feel that's where at least where at that time, nobody really, I mean, not many companies are moving towards Iceberg. But since last year, we found that okay, it's definitely a trend, right? Well, and everyone is moving towards Iceberg. So from my understanding, well, I also have a lot of conversations with our customers, especially in cybersecurity areas. What we found is that well, one of the key reasons is that well, I mean, they actually store a lot of like data because well, it's actually required, right? For all kinds of reasons, right? It's required. It's not like okay, you can choose whether to store your data or not. Well, it's required in cybersecurity space. And in most cases, well, yeah, if you use some CM tools, right? Yes, the SIEM, the CM tools. Well, I mean, then the challenge will be that well, most of these vendors actually charge people based on uh, the amount of data ingested. then it means that okay, probably yeah, if you ingest a lot of data, like I don't know, like 1 terabyte of data, I think 1 terabyte data is kind of small for those cybersecurity companies. I mean, if we ingest let's say uh 1 terabyte of data every single day, then it's definitely cost them a lot of money, right? And also people those companies don't really want to be vendor lock-in, right? Well, because well, I mean they just don't really want to just store their data in one single yeah, yeah company, right? So that's not affordable. Um and the other interesting thing I found is that well, people probably want to use different engines, right? Especially, I mean, traditionally people probably just use some search tools, right? Elasticsearch or some other tools. But this year but over the last probably 2 years, we found that okay, people are getting more and more excited about let's say tools like DuckDB, right? Or probably Puppy Graph. I think we will definitely see people are using Graph to do, I mean, lake analytics, right? Directly analyze data in on their data lake. And can you show us well, what you have ever seen and why they want to have do graph analytics on Iceberg? Or I mean, whether they want to have multiple engines or just use Puppy Graph or what?
Oh, this is interesting since I think for a lot of people still think Iceberg can only do the offline jobs, but actually since last year, a lot of things changed. Like DuckDB, ClearHouse, they both provide the real-time analytic on Iceberg, and what we are doing is this is also what we are doing. Like even your data in Iceberg, we can still serving in real time, like a sub-second performance. And since S3 is faster and faster every year, they claim the S3 team claim they are 3 times faster since last every year. I think it makes the performance very good, and also, of course, with some cache and other technology, we can make some sub-second performance. And this is pretty critical because uh, user want to have some real-time dashboard. Nowadays maybe also agent, and they don't want the user just hung there and waiting for the result rendering. So uh, they need the real time, and also we saw a lot of company, especially for cyber, their data is pretty complicated, and they also want a complex query. And before they reach out to us, they may do some denormalization and pre-drawing a lot of tables. Uh, but we help them get rid of drawings because the graph traverse between different tables. We still can make it something like sub-second. Yeah.
Yeah, I think someone mentioned that was Snowflake trying to enter the observability sector without Iceberg in 2020, 2022 already, but its auto clustering overhead is too much. Eventually, it has to adopt Iceberg, yet it was too late. Um, yeah, yeah, that's right. Yeah, we observed that. We did well. Yeah, we did see that. Okay, definitely. Snowflake try to enter the observability sector, but for I mean, in the observability sector, it's kind of like yeah, people have really found that. Well, I mean, yeah, like if for a certain company, if the data is not, they don't really have a lot of data, right? Or they just want to retain data for let's say probably 7 days. It's fine to use any kind of like a data warehouse, right? It doesn't really matter. But for a lot of in security space, the requirement is pretty different. The requirement is that well, you actually have to retain your data for Mondays, years, right? Or 7 years of data, right? If that's the case, then you cannot just yeah, store everything in a data warehouse is kind of too crazy because well, those vendors actually charge you based on the amount of data, right? Well, you preserved. So definitely, I think well, in most of the big companies, well, companies with huge amount of data, they will definitely choose Iceberg. And you mentioned the complex curve, right? So can I just use something like I don't know, let's say search or DuckDB or let's say some other system ClickHouse what to do graph analytics? Is it possible?
We have some customer use us to connect this data source, but by the SQL data warehouse itself, it's pretty hard. Uh, some of customer at least drawing 7 tables in one time, and even
Hmm.
more. And in this case, and it will be very slow, and also the cost is pretty high. And also like the snowflake story, and the investor who incubate Snowflake lately incubate Iceberg, Observe and for observability and the latest work for cybersecurity. And it seems that both of these companies are far away from the success of Snowflake. And I think the problem is because that if it's a digital native pure technology company, you are still using Snowflake, it's not very competitive. And the cost and also the performance is not good enough to win over other competitors.
Yeah, well, look, I'm not trying to attack Snowflake, but well, I mean, yeah, definitely. I heard, I heard some other guys. Well, actually, a lot of people actually discussing, yeah, talking about exactly the same thing. And but well, I mean, back to your join example, right? Where you say that people can probably join, need to join 7 tables, and in public graph, how do you guys will solve that problem? So how yeah, can you just make the join much easier or what?
Oh, so we define in because we modeling the table as graph, so there's no drawing anymore, and we are
Mm-hmm.
trying to do the graph traverse instead of drawings. In this case, for example, if you have multiple tables, we will define which table is type of nodes, which table is the type of edges, and after that, we believe any graph pattern or graph traverse will be a combination of a node operator and the edge operator, and the input is a collection of nodes and or a collection of edges. In this case, and then we can do the cost-based optimization on the graph traverse view.
Mm-hmm.
And so there is won't be complex things like left drawing, right drawing, full drawing, and then it's a consume a lot, and also the recursive drawing happen a lot. This is super expensive and very hard to maintain, and but for graph it's a kind of a BFS, so it makes things much easier.
Yeah. So do you store anything in public graph? So I think we definitely need to store some like the relations with among this data, right?
Actually, we don't need to have a storage layer and just rely on, for example, Iceberg. Uh,
Mm-hmm.
what we store is the kind of metadata, like if you, for example, if you have a customer profile table and also
Mm-hmm.
a product table, and also another table is called order history. Physically, there are three top tables, but order history is actually an edge between customer and product. Means customer A ordered the product B. In this case, all the edges are already there. And so that's why we like a normalized table. Like there are a lot of benefits. It save a lot of storage. You don't need to denormalize the table. And also the normalized table nature to be a graph when you do the modeling. So this is the remember let us remember the days for database 101. Yeah. So I think is the reason why the teacher tell us, oh, normalize things, normalize table is the best.
Mm-hmm, mm-hmm. Yeah, so yeah, definitely, definitely, it means that okay, you do not really need to, let's say that's why I have 10 terabytes of data, yeah, is stored in Iceberg. I don't really need to store these 10 terabyte data again, right, in public graph, right? You
Yes,
basically store some metadata, right?
yes.
And you can just run the traversal, right? Well, the graph traversal. So that's where you can definitely accelerate your query processing, right? For the query processing instead of, let's say, as you mentioned, joining 7 different tables, right? Let's say that's where if you use Trino to do exactly the same query, Trino probably need to join 7 different tables, right? And in
Yeah.
your case, because well, you actually store your metadata, the graph relations in public graph. So you do not need to traverse, sorry, you do not need join, you do not need to do a join, and you just run the query. Yeah, you just run the query and that's it, right?
Yes. Yes.
Yeah, that's super cool. Super cool. Yeah, and yeah, so definitely you I haven't finished the slides. Well, actually there are several other reasons why people choose Iceberg to for the in the cybersecurity space. In cybersecurity, time travel is definitely pretty big. Well, I mean, they actually need to travel back to certain time standpoint, time point to figure out, okay, what happened there at that time, right? Okay, whether there's because, okay, so here the example is that, well, what did the IM graph look like at the moment of the breach, right? They actually want to understand, okay, what happened there, right? Um, it's pretty important because, well, without this kind of certain kind of like so-called historical information or the yeah, the previous the historical information, then you cannot do this kind of analytics. And definitely the other reason here is that in Iceberg actually treats schema evolution as one of the key features, right? So yeah, if you ingest the data into Iceberg, you never need to worry about the schema evolution because it's definitely considered like a log change. But I know that's why in some OLAP databases or in some data warehouses, probably they're not optimized for this kind of like schema evolution, the workload that have a frequent schema evolution. Yeah. Um, so in what do we discuss? Well, from RisingWave perspective, what do we discuss? What do we observed here is that well, in cybersecurity space, they never wanted to do batch jobs. The reason here is that I mean definitely you can do scans. I know that's okay. People always do daily scans or whatever, right? That's fine. That's fine. But if you want to detect the fraud, well, if you want to detect any attacks, you definitely want to detect in seconds instead of like waiting for days, right? Let's say that's what you do. Let's say a daily scan, but some bad guys bad guy probably have already performed the attack, right? Then you probably have already lost everything, right? So what do we find here that the people do want to do the detections or in seconds or in real time instead of like using just some batch engines. And the other reason I found that people want to do real time is that want to do streaming in cybersecurity space is that well actually there are so many data sources, right? I mean you cannot just let's say ingest the data from one single computer, right? Well that's not quite possible, right? You essentially have a lot of like tables, a lot of data sources, a lot of data streams, right? It could be like some I don't know. I mean, here probably there's not example here, but well, I mean, it could be like the some employee stats, or probably some cluster stats, right? Or probably some logs and some external data sources, right? And you have a lot of table, and all these tables are essentially streaming data into your system. So essentially, figure out okay whether yeah you want to do detections or you want to do this kind of like fraud detections of cybersecurity detections in real time. Because well, if you just let's say do a bad job every 30 minutes, it means that well you actually have to run the entire let's say I don't know 7 table joins or probably 10 table joins from scratch. It is very expensive. So what do we find here that people actually do real-time streaming joins in order to to detect okay whether there's certain kind of like detections in real time. And that's the detection part. The other fun reason we found is that okay, because we actually noticed that because I actually as I mentioned, a lot of vendors actually charge people based on the per gigabyte of data ingested, right? So, but for in cybersecurity domain, they actually have a lot of like a redundant data or some data that don't really need to be logged, right? So people call it like yeah, some people call it as a telemetry pipeline. So that's what we can actually clean up some certain kind of data, right? To do duplication, I'll probably do some sampling, to do some aggregation on the fly instead of like just dumping everything into Iceberg or into your data systems into your CMs, right? Yeah, that's what we observed. And about what in cybersecurity space, it's to summarize they actually need to have a streaming solution, not just because, well, for two reasons. The first one is to detect attacks were in real time. And second, were to cut cost, right? Or to cut cost, so that's what they only need to store the data that they need, right? Where they can drop off all these kind of random data, right? And tell us more about okay why they need to have graph. Because what we definitely hear you out that okay people want to do seven table joins or 10 table joins and they find that's where they could not use, let's say, I don't know, Trino or some other solutions, and it could be very expensive, and they actually need to do, let's say, graph traversals, right? And but my question here is that why we need to have this kind of like yeah, why we need to do this, right? Why we need to have seven table joins? Yeah.
Yeah, well, this is a long story. Like,
Mm-hmm.
this is always a big dilemma whether to use data lake or use graph database. Like, as I mentioned, the Wiz and the Lacework, they were competitor. Lace founded first and by the Snowflake investor, and so the Lacework have a bigger team and using Snowflake to implement something called a polygraph. So the product is actually a graph, but they use SQL to support it. And then Wiz is just using the Amazon Neptune, the
Mm-hmm.
graph database of on Amazon graph database. And then the interesting part is that Snowflake is a kind of a cheaper. Yeah, it's a expensive, but much cheaper than Amazon Neptune. And but the development is very hard. And because the product itself is a polygraph, and they use a lot of workaround to let SQL express the graph, like several hops and the blood radius, and find the attack path. And it's with development is much faster with a much smaller team. Like I think when we only have 50 people and uh, Lacework already have 200 tables. Oh, sorry, 200 people in the team. And then with Win deliver feature much faster and win over Lacework very fast and big. And then is everybody knows that is the 32 billion acquisition from Google. And this is but then for most cybersecurity company, they have to choose from graph database, which is super expensive, or they just use a workaround like a Trino or Snowflake to express the graph in a SQL way. But because so many drawings and also recursive drawing, and make the development very hard, and also the cost performance and is also a big problem. And you can see that sometimes, like the here, like attack path or block resist, and the secret script you can even not readable by the human being. And also the problem happened when there is a lot of relation. The single rows is cannot express any potential risk. For example,
Mm-hmm.
some of the user want to ask, after vulnerability was released, and then some people will ask, in my environment, which virtual machine installed the software containing this vulnerability, and at the
Mm-hmm.
same time, it was not protected by any security group. and exposed to public IP. So if you cannot answer it in real time, before it's not a big deal. If you finally find it, like offline job and find it is okay, and since some of the enterprise still have Windows XP and the vulnerability is there already, but the attackers uh, bandwidth is limited, so they can only try some high value target and then to scan different vulnerability after it's released. But now the things changed, and all the attackers are using agent, and you can see the ranking of hackers. They find the detect the vulnerability and who find the most vulnerability recently. And the first one is the AI company, Expo, just use the agent to find all this stuff. Now is a race between the attacker and the defender, and after a new vulnerability is found, and
Mhm.
then it's really important whether we detect what's the potential risks in our environment first, or the attacker run their agent and the agent find you first, and then I think it's a big change from the cybersecurity industry. And oh, by the way, a lot of this insight is from a panel of with CTO, and he share a lot of this. And I think it's a big opportunity since the cybersecurity stock, company stock drop a lot, but I believe that it's actually a opportunity since before that no one care. Uh, Maybe the vulnerability was there for half a year, still no one attacked it. But now I think the cybersecurity company who have the real-time capability can charge more because he defend more attackers. And I think maybe the potential good news for the uh, cybersecurity company. Since now maybe the investor believe that, oh, if you cannot defend it, and then the stock price will drop. But I think the more valuable is that it's a more harder problem. So the cybersecurity company who have the strongest technology, maybe also the strongest data infra, will be very compelling, and then the market will be even bigger, I think.
Yeah, actually, you mentioned one thing that's very interesting. I know that's what, yeah, I know that's what cybersecurity company stock dropped mainly because of the Anthropic thing, right? Well, they actually launched the model. They didn't really launch the model, but they just mentioned that where they have a model that can um, uh, self detect self-detect bugs, right? Is it? Like, yeah. And I also know that okay, people are actually using agents to detect well they to actually do attacks, right? Well, and do have you ever seen let's say some companies, some cybersecurity companies started working on that part? Always mainly because well, okay, they feel that case kind of like early and they don't really care.
I think now is like the posture management and exposure management is more and more real time. And before that, some of them just collect the data maybe per day, and it's still a good software and make a lot of money. But I think now things is a change.
Yeah. Yeah, I do. Yeah, I do see. Uh, see. There's one guest, Eric, and mentioned that he per join. Eight data sets and streams in this example into a denormalized table can be quite challenging, especially these eight sources don't arrive at the same pace. Yeah, that's right. So basically, that's right. Well, so I think it's also the question is also about okay, when we want to do, let's say, yeah, when we want to do, let's say, streaming joins and when we want to and whether we want to use some certain kind of technology like watermark, right, or like time windowing, like I know that's where everyone is using time windowing, and whether they want to use SF joins or whatever, right? So in RisingWave case, what we found here that we definitely it's a very challenging problem, and it's essentially it's also a high value problem. Why? Think about okay, if we want to have so not just in cybersecurity, but also in we actually do a lot of risk management in payment companies and P&L. P&L calculating P&Ls could be a little bit different, but well, I mean, for payment companies, they actually do underwriting. They actually do, let's say, the fraud detection. They actually need to join multiple tables. Because, well, let's say that, okay, we have some guys who have swapped a credit card, and we really want to detect, okay, whether the credit card is a swap is, we should allow this for transaction, right? If you want to do this kind of detection, we actually need to join the customer table and your credit card information table and probably some your location table, currency, policy, and some other all these tables rolled together, right? But definitely, I know that okay, some of the tables are static table, and but well, you have to join these probably I don't know 10 tables or 8 tables in cybersecurity space, well, I think well the challenge will be that well probably there are uh, a lot of tables that are streaming tables instead of just like dimension table, static dimension table. How to join these well, static tables well, together? Sorry, streaming tables together could be very challenging. So RisingWave is heavily optimized for that for streaming joins, especially let's say 10-way joins, 20-way joins, because well, I mean, in because we actually optimized a lot for the storage part, state management part, as people know. For stream processing, the key challenge here is not about okay, just let's say do filtering to do something like sampling, it could be easy. Aggregation, it could be easy, right? Well, every single query engine can do that. But so the challenge here that if you want to do streaming joins, let's say 8-way joins, then you actually could end up with a large state, right? Managing a large state. If you want to manage such kind of large state, then you definitely need to care about okay whether you want to have how you want to manage this large state. In RisingWave, we actually have the so essentially have the decoupled convenient storage architecture. So basically to maintain the cool storage, cool state in S3, and we also have the disk cache for in stored in EBS to cache all could be like NVMe. It totally depends on your configuration. To cache the data to ensure that okay, you can have large state, but in the same time, it will not affect the performance, and you can still do let's say 8-way join, 10-way join very efficiently in real time on the fly. Um, yeah, and also regarding um, yeah, so that's a per join. So basically a streaming join part, and the public graph essentially handles the another problem. That is okay after the data landed in your iceberg, how you query it, right? For that part, the join is also expensive. The main challenge here, that's why in the main challenge in that place is that okay, look, okay, you have to do multi-way joins and but well, if you use some OLAP engines to do multi-way joins, then it could be very expensive because well, they actually need to join too many tables and it's 4 table scan, right? Because well, you have so many tables and it actually end up with a 4 table scan. But for public graph, it's like okay, let's just store the metadata and we can we yeah and we can do graph traversal. So, actually, one quick question for Wimo, and so for in your case, well, I mean, if let's say the you mentioned you will maintain the metadata, right? Let's say that's why I ingest more data into Iceberg, and how will you update your metadata?
Oh, actually, in our case, the metadata is kind of only related to the table schema. So
Uh-huh.
after you have more data, the metadata won't be increased. For example,
Hmm.
uh, for the previous case, like a customer table, product table, and order history, what we store is only like, oh, customer table is a type of node, and product table is a type of node, and order history is a type of edge, and the customer ID of order history is from the product ID of order history is two, and after that, we this is all the metadata we have. So even when you have Python-based data, and our metadata is only related to the numbers of tables, so it's not related to the table size.
I see, I see. So let's say that's right. If I ingest more data into Iceberg, you will not index all this data, right?
Yes, and at same time,
Mm.
uh, because Iceberg itself has a lot of metadata, like
Oh,
also
yeah.
you can have the index like Bloom filter, the order, and we can leverage that. And this is a trick here.
So you mentioned so what you mentioned is that you actually can reuse the, let's say, the rest of catalogs metadata, right?
Yes, yes. We're trying to use them as much as possible, and also we help some of customer to do the optimization, like build index. And of course, it not only benefits ourselves, but also benefits the SQL Core engine and maybe
Uh,
other
so
tools as well.
so how do you benefit the SQL query engine?
For example,
Mm.
if you have still the same example, and if you can ranked by the customer ID and sorted the order history table by the customer ID, and then the locality will be much better. And if even you cannot sort it, you can still build some Bloom filter or the order index on top of it. At the same time, if you still draw in the tables, and because there is for the foreign key there is some kind of index, the still can make it faster.
Hmm. Yeah, that makes sense. Yeah. Cool. Yeah. So yeah, we mentioned about what the stream about why we need to have real-time stream processing and why we want to have graph processing in cybersecurity domain. And what we observed here is that we essentially people can just let's say ingest the te telemetry data, right? So from, I don't know, from your Kafka, from your Postgres, from your syslog, from, let's say, VPC flow, or probably some other places, right? Your audit data in just in all these kind of things into RisingWave. One thing I want to mention that, well, essentially RisingWave not only supports for the streaming ingestion, but also supports batch ingestion, which means that, okay, yeah, you can just let's say do batch scans, right? Well, I don't know, every 30 minutes to do a scan and to ingest the data from there ingest the data from the batch sources. So we actually were ingest all this data from everywhere and then do it joins and do very complicated joins. Could be like yeah, multi-way joins, 10-way joins, 20-way joins. Do also in addition of we can also do deduplication, whatever, right? And then move the data and then so basically send the result into Iceberg. But definitely we also the other pattern here that's key because people actually need to do detections, right? So people actually can use RisingWave to serve their applications, for example, serve their notification alerting system, right? Yeah, you definitely want to alert your humans, right? Well, so that's where the humans can figure out, okay, get notified. Okay, there's some bad happened, right? So I do want to do some investigation. So yeah, RisingWave has the storage, has a super low latency storage, and also have a webhook sync to notify your alerting system or to serve your alerting system or serve your notification systems or serve your real-time dashboard. So after syncing a data into Iceberg, we can use for because it's a centralized place and they have all this kind of like dimension tables, yeah, the fact tables where you have everything, and you can decide, okay, what kind of query engines you want to use. Probably use Public Graph for graph analytics. Or if you think that, okay, look, well, I just want to do some local analytics using my local machine, then for sure go ahead with DuckDB, right? So because DuckDB is super powerful in terms of yeah, it's definitely a really good OLAP engine, which is open source and embedded, right? Um, okay, yeah, that's so yeah. Yeah, I think I've already mentioned here. Yeah, it's about the streaming native, SQL native ingestion, in-flight join, deduplication, enrich, and continuous Iceberg sync. We actually also will optimize for that part because for Iceberg it's a little bit tricky because Iceberg was not used to, yeah, was not, wasn't originally wasn't designed for streaming ingestion, but these days, well, you can see that in Iceberg community we actually introduced a lot of features that can help people to ingest the data from streaming sources. And we at RisingWave definitely optimized a lot of parts for in Iceberg Sync. So yeah, we can probably discuss about that offline. Um, and here we actually have Jess. Well, I know that we have a demo, and I was wondering whether we can have whether we could do some show people okay how we can yeah do this kind of like detections for as well as analytics for in the cybersecurity space.
Yeah, sure. Let me just go ahead and share my screen. Oh,
Sure.
I
Yes.
think I
Go
need
ahead.
to send a request.
Yeah. Let me stop
Perfect.
sharing first. So yeah, I've already stopped sharing. Have you shared your screen?
think
Oh,
so
yeah,
I
I
kind
can
of
see your
have an
screen now.
perfect. Yeah, so I have an end-to-end demo prepared over here. So I think I'll start off with kind of the setup process. So I guess we're going to put on our inspector finding hat today, and kind of look at a bunch of inspector findings that come in and see, hey, what vulnerabilities might exist within our system. So over here, I've actually already gone and set up the Docker Compose, which creates Kafka for the streaming data, and then RisingWave to process it. MinIO is for the Iceberg table storage, and then PuppyGraph can actually connect to both RisingWave and MinIO to kind of do the graph querying. So over here, I'm just going to create the topics really quickly. And then from there, with RisingWave, we'll actually register these Kafka topics as sources, and then create materialized views, incremental materialized views that PuppyGraph can query from. So if you want real-time security insights, this is how you would do it. And then also we're creating the sinks because that data will also be put into the Iceberg tables. And so for that one, it's configurable how often or how quickly you want it to kind of put that data in. But for default, it's set to 60 seconds as well. And then we're just going to put the snapshot data so we seed it, and then we can run the incremental data creation. So it's based off of real data that I've taken from NIST. Um,
Mm.
and so, yeah, over here, I think if you like looking at numbers go up, I've kind of have it simulated. So it kind of shows that even in the lull periods, you're still going to get inspector findings, which is expected. And then over time, it's going to start spiking and we're like in panic mode. And then once you kind of start resolving it, these security findings will probably go down. So that was the setup process. I will say it is kind of quick just because if you're actually doing analytics, you should probably have that set up. But yeah. And then over here, I've actually gone ahead and uploaded that graph schema. So this is how PuppyGraph understands how you want your tables mapped as your graph, right? This one over here is from the RisingWave direct querying. And then over here, I have the Iceberg findings that come from the Iceberg tables themselves. So the reason
So
why
you
I just
have
have that.
here
Mhm.
you can query both RisingWave and Iceberg, right?
Yes. Yep.
So
So
which
I've
one is
actually could.
which one is a RisingWave table and which one is the Iceberg
Oh,
table?
yeah. So Iceberg, this one is MinIO and then via the REST catalog connectivity. And
Oh,
then for RisingWave, we'll connect via, I think you can treat it like a PostgreSQL.
for sure, yeah,
We
yeah, it's
can, yeah,
Postgres
we can,
compatible. So yeah, you can
yeah,
directly use Postgres for
exactly.
the interface. Yeah.
Yeah, and then I think you can also query the Iceberg tables via the Rising Wave because it's JDBC compatible as well. But I've kind of just gone with this route because it's what I'm more familiar with.
So
But one really,
how many sources you can spot? Well, what kind of data
oh
sources you spot?
Yeah, so for the data sources we support, we actually
Okay,
support
basically
multiple of
like
them.
yeah, data
Yeah.
lake and yeah, data warehouses. Yeah,
Yeah.
that's great. That's great.
And then, and then like what Waymo was saying just now, it's basically because the metadata is how many tables you have. I think the number of catalogs will also kind of increase the complexity, but we are able to be that federated query layer that kind of just connects across your data sources, so you get a unified view of the data. And then one really interesting thing that I kind of wanted to point out is because of how we're kind of using the iceberg sync, you'll see that there is a slight difference between the actual AWS inspector findings. Um, and then I think this one you have to divide it by half just because I ran it earlier. So there's already some data inside the iceberg tables that didn't clear. But
Mm.
actually, the AWS inspector findings comes directly from RisingWave itself. So that one tends to actually update a bit faster. So we can go ahead and start creating your data. And let's say you just woke up and you're like, what do I have to do for work, right? So maybe you show me the most critical um, findings in the past 10 minutes, right? And then from here, your AI agent is actually just going to be able to reference that graph schema as it's doing the querying. So it's kind of this ontology enforced layer where you can only query relationships that exist, which can be a bit different from SQL, where you can join as long as the two keys have the same typing, essentially. And if you're using agents, this is kind of what your agents would be doing. They'll kind of send their queries to PuppyGraph MCP, and then it'll get back the responses that it can then use to route its observations and actual data from your data sources. Um, so over here, we see all these 20 findings are active and critical. And so maybe I see, hey, this has the highest inspector scoring. So I say, if this instance gets compromised, what other resources should I care? So if um so this is kind of like a blast radius search from there, where it's just saying, oh yeah, it says blast radius, where now that you understand which instances you care about, you kind of want to map out, hey, what happens from here, right? Um, and then all of this is on data that's streaming in. You can see it was first observed at I can't remember the UTC, but like I think the data is all kind of coming in real time as well. And then one really interesting thing, I guess, if you're working with your AI and stuff, is that it usually we have it issue cipher queries just because there's a lot more training data on it. But each one of these would actually have been a SQL join. But for puppy graph, we kind of skip that because we're going more graph traversals. So we mostly, if you're using JDBC, it'll be selective filter queries that get sent down, which is a lot faster than doing these costly table joins. And then from here, you can say, hey, um, these are probably the regions you should care about. And then this instance is particularly dangerous, so you might want to go ahead and fix that. Um, and then if you want to, you can also just, I think, if you want more control over the queries itself, you can go to the panel and kind of just edit that. Um, and then just run it to, oh, let's see. Uh, I'm probably not going to try to debug this in real time, but yeah, that's kind of the general idea of it. But yeah.
Okay, that's fine. Yeah, that's fair enough. Yeah. So, one question for you. So, in this case, well, so you mentioned that we can definitely query both RisingWave and Iceberg. And in querying RisingWave, you directly fetch the catalog, right, inside of RisingWave, right? So you do not really index the Rising the RisingWave data, right?
Yeah, we don't need to do it since also we want to catch the latest updates. So it's a lazy fetch.
Yeah, yeah. So basically, that's the thing, right? So you actually directly index the catalog. Well, in ResonWave's case, well, yes, yeah. So definitely, yeah, we directly index the catalog. And then for the Iceberg, yeah, it's the rest catalog, and I don't know, Iceberg tables. Do you guys post? yeah, you guys definitely support S3 tables, right?
Yes, yes.
And all the other, yeah, all the other catalogs. Um,
Yeah. And so I think for this one, I think we offer different caching strategies, but because we wanted it real time, so for this one, I'm just pulling directly from the data sources itself. So this is configurable as well. But yeah. Mhm,
yeah, this is a materialized view from RisingWave, right?
mhm, mhm.
So yeah, so basically what it means is that well, yeah, we have let's say we have 10 different materialized views in RisingWave, and you can directly attach to RisingWave and to do let's say graph traversals across these 10 different tables, 10 different, no matter whether it's tables, materialized views, whatever,
Yes,
and then you can do all this kind of analytics, right?
yes, yes.
That's cool. That's cool. That's cool. And also the other question here that's for Iceberg, well, it's you know that's well, okay. In Iceberg, we have the time traversal, right? So time travel queries, and you guys support time travel queries as well. Yeah.
Yes, we leverage the iceberg to do it. Just when we fetching read the packet file, and then we will use this information.
Okay, so yeah, basically that's the because everything is stored in the REST catalog, and
Yeah.
you can use for the REST catalog to fetch the basically the yeah the time point, right? You basically can travel back
Yes,
and do
yes.
analytics. Yeah.
And even you can compare some like the topology 1 year ago was different uh, between the snapshot of last year and this year.
Yeah, we actually found that well, time travel queries are becoming more and more important. Well, I mean, RainWave, well, I mean, definitely Iceberg supports for the Iceberg supports the time travel queries. And then in meanwhile, actually, RisingWave also supports time travel queries, but for in a different way. In that, we actually because we actually have the streaming flow in, right? For streaming, and we actually can take snapshots. Um, so you can decide, okay, how frequently you want to take a snapshot, and you can go back to any snapshot. So in trading uh in trading payment services it could be like feature engineering, and they want to travel back to a certain time point and to understand, okay, what it look like, what the features look like in that certain time point. And in trading, they want to do they want to do analytics on certain snapshots, right? What they're quant analysts, what they want to do this kind of things, and they just use for the they just use RisingWave to travel back to a certain time point. Yeah, that's what we yeah that's a pattern we found. Yeah. Um. Yeah. Cool.
I
Yeah. Go ahead.
I also really like this just because it's such a composable stat. And so even though you can run graph analytics, you're still able to access like all your SQL functionality. So I know RisingWave also supports SQL queries, so you can run that side by side, especially for agentic workflows when you want to switch between modes of running your aggregations of SQL versus your
Mhm.
complex multi-hop queries in PuppyGraph. Yeah,
Yeah.
cool.
Okay. Yeah, cool. Essentially, yeah, we're running out of time, and yeah. So if you are interested in no matter whether it's like in streaming or in graph analytics or in Iceberg, so yeah, feel free to reach out to us. For I mean, yeah, Wimo and Jace, well, they're always on LinkedIn, right? Well, and you can definitely also visit their website. And for RisingWave, I mean, I'm always here. I'm always in Slack committee, and I'm also always in LinkedIn. And feel free to talk to me, and just DM me, right? Well, yeah, don't really just send email to me. I mean, because well, you know that's why these days well agents send out too many emails, and I just don't really want to check my email box. But
Yeah.
well, yeah, reach out to me on LinkedIn or probably on Slack committee so that we can have the conversation there. All right, cool.
Mhm.
All right.
Thank you.
Thanks everyone for attending the
Yeah.
webinar, and thanks Wimo and Jace to the demo. All right. Thank you.
Thank you.
See you next time.
Bye bye.
Bye.